the opportunity and maybe continuing the theme of clinical disease. So I'm going to provide a brief overview of the potential effects of ryegrass endophyte toxins on cattle, talk a little bit about the effects of those on milk production, look at some emerging mycotoxins, and also talk about dark cutting in beef. And that's been a particular interest of ours in the last little while, and I'd really like to thank Dieter Moll from Biomin and some help that he's provided in that particular instance. I'm normally interested in quantitative review, and so in this case the very, very difficult area of toxicology comes up, and as kind of a scientist who likes to drill down and be very quantitative, I really struggle with plant toxins because it's very hard to create those circumstances and actually study them in a scientific context, so we have to study them by and large in a clinical context, and that raises all sorts of problematic issues. And that's why part of this talk today is very much quantitative review rather than qualitative review, but then I go and stick on my dirty clinician's hat and get down and dirty and give you some case reports, which are of course ends of one. So that's how life is, isn't it? So the best evidence is randomised controlled clinical trials, double-blind, multi-centre, especially backed up with biochemical, hormonal or genetic support. And, strong evidence is randomised controlled trials, prospective cohorts, moderate evidence, physiological studies, retrospective analysis cohorts, weak clinical trials, case studies, the stuff I'm going to present to you. And of course analogy, and the best evidence of all is my favourite, which is meta-analysis. I'm just talking now briefly about Australia and New Zealand, but look, I'd really like to expand out the horizon and say this really does relate to the intensive pasture-based regions of the world, the sort of stuff we're talking about. We may have specifics around Australia and New Zealand, but I want to extend out that vision. And this is typical of some cows grazing at pasture in Australia, and we also run a heck of a lot of beef cattle, also largely on pasture. And the stuff that I'm going to talk about today particularly applies to our more southern zones where ryegrass dominates. One of the big challenges about the endotoxins that are produced from ryegrass from Neotyphodium lollii is that there's so many different alkaloids produced, and many of them are potentially toxic, and even worse still, they have metabolites that are particularly toxic. So we're actually dealing with a very complex series of observations because, again, very much like Professor Diaz before, the situation is that we're just not looking at a particularly clinical observation. We're talking about a raft of different things that are integrated, and therefore the impacts of these toxins are not entirely predictable. So, there's over 200 alkaloids that are produced, and many of them toxic. Neotyphodium lollii, Claviceps purpurea, they both are capable of producing ergopeptine alkaloids, and just recently I found a paper that showed that, for example, ergosine is transformed, at least in the sheep rumen, into lysergic acid. And when we're talking about some of the case studies I'm going to talk to you about later, I've got to say that it's been a long time since I've genuinely felt at risk of being killed doing what I do at work. But dealing with some of the cattle we dealt with in one of these particular cases, I assure you that there was almost a change of underwear needed. Okay, so talking about these things, possible impacts of endophytes, go on and we can look at some of these. So there's evidence of certainly central nervous system disorders, and there is a causal basis evident. Okay, some of these animals are incredibly excitable, incredibly dangerous when they're challenged by these things. I've seen cattle literally charge solid walls, I've seen them charge people, I've seen them twitch and attack vehicles. And so when you've got those sort of central nervous disorders present, they're extremely nasty. There is trial evidence of effect, it's present, and the assessment of the evidence is that it's strong for these alkaloids to cause central nervous disorder, and we'll see some photos of some of these cases a bit later. Reproductive impairment, again, zearalenone, again, we've got presence, weak to moderate in dairy and beef, but it's very likely the case. Polioencephalomalacia, there's an association between these ryegrass endophytes and outbreaks of polioencephalomalacia. We don't understand the causal basis. The evidence is weak, but it's certainly the association is present. Looking at reduced immune disorder, it's present and it's weak. And then selective ingestion of pasture. And we heard a very good presentation on acidosis previously, and I'd point out that one of the risks for acidosis in these pasture-based systems is failure to ingest pasture because pasture is toxic. Okay, these animals avoid these pastures. And so what you then get is a selective intake of the grain portions, but you don't get the forage portion, and so you've got problems with the selective ingestion of pasture. You've also got problems then with maintenance of legumes in your pasture swards. So selective ingestion of pasture, while it may not appear to be a very substantial issue, is a substantial issue in these systems. Possible impacts of endophytes include lower weight gain, increased somatic cell count. The evidence for that is very weak. Reduced clover content, scouring, that's quite possible, quite possible. We've dealt with an extraordinary case in horses where these conditions led to massive mucosal edema associated with an endophyte inserted into a fescue, and with that massive intestinal edema, scouring was present. Interestingly, cattle exposed to the same sward were vigorously scouring. But again, the evidence is only weak to moderate over the whole database. Fat necrosis, very weak, and lameness. So there's a lot of things that happen. These are cattle that were reasonably typical of this area in which we're conducting the research on dark cutting. And what you can see there is an animal that has collapsed. It's twitching so much. All these animals were twitching. They were basically moving, hypermetric gait, staggering. I would have liked to have put in the video because the video is quite spectacular, but wasn't game enough with the technology. But there's an animal just going over and it's just collapsed into the feed. And that's because it's completely unable to maintain stability. And these were the cattle on this island where particularly some of these, really dangerous and hyperactive animals were. Beautiful place to visit, but does cause some problems. So ryegrass staggers. Again, lolatrine is probably the major issue, although having looked at these other potential alkaloids that could be produced, I'm not sure that it's simply just lolatrine. What you see is head tremble, muscle fasciculation, head nodding, swaying, staggering, stiff-legged gait, hypermetric movement, falling tetanic spasms, and the animals will suddenly recover and they'll look apparently normal. They will flash back, okay? Sometimes they'll travel along normally for several months and then suddenly develop again these sort of hypermetric symptoms. So while there's apparent recovery, it may not be complete. And certainly under pressure, you'll see these animals start to show signs of central nervous disorder again. There's very high morbidity. In this mob, it was nearly 100% in that mob of Herefords that you just saw. There were nearly 100% of the animals affected by staggering gaits. It was quite interesting to go back and look at the video. There were animals you saw at the time you didn't recognise as being affected by grass staggers, but once you watched the video, you could see there was actually muscle fasciculation or hypermetric gait once they moved. So it's really quite extraordinary. Mortality, however, is pretty low. A lot of the mortality is associated with animals becoming cast or injuring themselves while they're undergoing these bouts. Weight loss has been reported, but it's not necessarily been confirmed. And as I said, other neurological conditions can occur, and there's been spectacular herd stampedes that we've seen. People moving dairy cattle into a shed and suddenly finding that the dairy cattle have stampeded, gone through fences, broken out. So it can affect a whole mob. You see unsettled behaviour, and these animals can be completely uncontrolled. So let's now move on from the central nervous disorders and have a look at heat stress. Is there a causal link? Yes, there is. Ergovaline causes vasoconstriction. Again, it might influence plasma prolactin, and it does. And of course, lolatrine B may be involved in terms of this muscle fasciculation that you see. Strength of evidence is actually pretty strong, especially out of the literature to do with the endophytes in fescues out of the US in particular. There's many strong physiological studies. The field data is moderate, but you do see increased respiratory rates and salivation, and injections of ergometrine and ergonovine also cause the symptoms. So one of the big problems is that when you're dealing with again, field observation, that you deal with confounding. Now, one of the problems is that you do see expression of the plant endophytes when the plant is under pressure itself. So you often see that pressure exerted over the summer months, so that you have confounding between the heat of summer, expression of the toxin within the plant, and then ingestion. So these are the problems with trying to interpret the field data. However, prolactin heat stress occurs in summer. Prolactin concentrations surge in the week before calving in terms of the cow. Now, why is that important? Because in that week before calving is when cattle, dairy cattle, are particularly sensitive in terms of their value of prolactin. After calving, prolactin doesn't seem to play much of a role in dairy cattle in terms of maintenance of milk production as opposed to some other species. But it is important just before calving, so that if you've got a calving situation and you've got a surge in ergovaline at that time, it could be a very important impact on the capacity of those cows to produce over-lactation. So you've got that lobular alveolar development, which is encouraged by progesterone, estradiol, 17-beta and estrone, but the prolactin is important during this phase, and that's been demonstrated using reserpine, which is the Rauwolfia alkaloid, which then has that impact of stimulating prolactin secretion, and it does, in artificial induction programs, allow a much greater expression of lactation. However, it's not legal to use. So, bottom line, here's where this risk of confounding comes up. If you look at the period 1 up the top, it's the peak period of risk of toxic endophyte products being produced. So as I said, Australia, you've got to think reverse of America. Okay, so Northern Hemisphere, Southern Hemisphere problem here, but as long as you kind of think that your period, if you're Northern Hemisphere people listening, you're going to be the opposite of these. So what we're looking at is around summer, you see much more expression of the toxic endophyte products. However, that also, of course, is coupled with poor nutritional value of those products here. So that when we're talking about loss of production, you've got to be damn careful because the grasses are just not of the same quality. Here you've got the key risk for prolactin suppression with spring calvers, and then you've got down here the key period of prolactin suppression for autumn calvers. So it's particularly our autumn calvers that I worry about the risk. And when we look at the diets that are put in front of these cattle, often the diets that are put in front of the autumn calving cows are every bit as good as the diets put in front of spring calving cattle, but what we often see is a lower production in the autumn calvers. Now that's influenced by so many other things that one wouldn't want to get carried away, but it's again another possible indicator of a loss of productivity in autumn calving animals. If we look at the impact of ryegrass endophyte, and particularly ergovaline in this case, on milk production, in fact, what we can find is that there is reasonable evidence, if we take a quantitative approach, suggesting that it is a player. So this is the difference in milk solids in studies that have either been done as randomised controlled trials or observational studies, and these are the sorts of responses we're looking at. So we're suggesting that perhaps, you know, a 10% reduction in milk production associated with the presence of ergovaline and ryegrass is probably possible. So now I'm going to go into the case reports. This is the case report that we're going to start with a pretty good producing herd. This is in 98, 99, so it's not exactly new information. But what you've got here is the historical controls, unfortunately, but that's how it is. That's a case report. So what you've got is milk production, and you're looking at milk production before, you're looking at milk production during a period of exposure to a ryegrass high in ergovaline. Now, the nutritional quality on this ryegrass was really good. It was outstanding quality silage, but it had extremely high levels of ergovaline in it. And what you can see is that while butterfat was not affected, milk protein content was not affected, the yield of butterfat and protein, of course, was well down. And what you've got is controlling for things such as average days in milk. They're reasonably similar. Milk somatic cells somewhat increased. So that's the case report. How does it look in terms of just looking back at the data, the historical context? This is the herd moving along. This is when the feed started to go in, and that's the drop there, and that's the recovery from the moment the feed was pulled out. So the feed was basically pulled out about here, and what you can see is a very marked recovery of that herd's production. It's really quite a nice case report, this one. So then looking at just a couple of examples, this is a herd where you can actually see these cows are eating incredibly selectively. They're actually in there looking for clover. They're looking for pasture that they can eat. They have walked past lush pasture to try and find clover in this case. And these animals are heifers being raised, but these heifers were suffering from an acidotic condition. They were getting laminitic. And why were they doing that? Because they're standing in this grass and they're just not eating this grass. The only thing that they're eating is the grain they're being supplied. So again, these grasses, very, very unpalatable. Cattle are reasonably intelligent about avoiding feeds they don't like. There was a nice case study reported in Australia, well, scientific study reported in Australia, I heard the other day about preferences. And cattle are able to make up their mind within 2 seconds as to whether they like or dislike a feed. So really quite remarkable in their ability to do it. So conclusions. In the paper you see that there's some information from Reed, who did a widespread survey across Australia and New Zealand, showing that there's a high prevalence of these toxins when he did the survey. So there is a high prevalence, which means that a lot of cattle in that zone, the southern zone, primarily fed on ryegrasses and supplemented with concentrate, are exposed. It appears more likely that the potential effect of these toxins has been significantly underestimated rather than overestimated. And it was interesting when you were talking earlier, Professor Diaz was talking about reasons why we believe mycotoxins are more important. I'm going to give you another one, and it's a veterinary bias, okay? But I think veterinarians have done a wonderful job of eliminating many of the substantial diseases of cattle. And what we're left with now is a much clearer prism through which we can see the other effects of disorder. And one of those effects of disorder that we can now clearly see is the impact of mycotoxins. And so I think it's very logical that mycotoxins should be raised up the list in terms of concern as we start to understand those better and see them through a clearer prism without a lot of the other diseases present. So a particular concern for the potential is to influence mammogenesis. And of course, what we find now is that the agronomic companies are now becoming acutely aware of the effect of endophytes. There's a lot of use of novel endophytes now around across the world, the AR37s, the NEAs. These are all powerful tools to start changing the nature of the mycotoxins that are being produced. We need to be very careful in terms of the process. Because this area is so damn complex, there have been attempts in the past to produce novel endophytes, and several of those novel endophytes have failed, including that rather spectacular horse case I told you about, where horses were simply dying on these pastures. So that was with also a novel endophyte. So until we thoroughly understand the biology of the mycotoxins and the alkaloids that are being produced, I think we're going to struggle. The other point that should be made in that context is that the expression of different alkaloids out of these endophytes and grasses is a function of the unique environment and the interaction of that environment with the specific endophyte and with the specific grass cultivar. Okay, so conclusions. Potentials for interactions between ergovaline and heat stress should not be underestimated at all. It's a really significant one. And behavioural problems with low latreme or neurotoxic alkaloids are observed. Research would be really good, I think, to look at this effect of ergovaline on mammary land development. I think that's probably a substantial area of work because I think it would also lead to some more basic understandings about that late gestation, early lactation period, and I think that would be worthwhile. And so the effects of milk production of cows exposed just before calving to endophyte toxins would be worth looking at. The next case I'm going to briefly present is an extraordinary case, probably the most devastating outbreak of any disorder I've ever seen. There was one in California, I think, that might have been similar, but this was very powerful. What we saw was a sudden milk drop in 94 out of 678 dairy cows. We had a 24% morbidity. These animals were grazing a dryland pasture. The mortality was 19 over the first 30 days. So if you look at that on a case mortality rate, you're basically talking about, about 20% of them dying. I don't think I've ever seen sicker animals. It's really quite an extraordinary case. The animals, basically clinical signs of recumbency, per acute photosensitization, inflamed coronary bands, conjunctiva was inflamed and eroded, periauricular edema, distress. These animals were bellowing in pain. They were grinding their teeth. They were basically asking for help any which way they could get it. They were distressed, kicking at the sides, bruxism, which is grinding teeth, discomfort, weight shifting, vocalisation, and pain and depression. The milk drop was greater than 20% between 74 hours before to the onset. And in 148 cows, there was a mean drop of about 19%. So that's bruxism, just cow grinding her teeth. Edema, submandibular. Severe erythrema of the teats, those skin's about to slough off. Hunching and bruxism. There's a cow she's obviously not drinking, she's incredibly dehydrated. Periauricular edema. There's the sloughing. It was amazing to see maybe 30% of the cows are just sloughed sheets of skin and scabbing, and there's ocular discharge and frothing at the mouth. This is the suspected culprit. We've never seen that mould in a lot of grass we've looked at. What you can see is this black-green mould. What you can't probably quite clearly see is the chlorosis or the photosensitization of the pasture itself. In fact, the chlorophyll is almost drained from the areas around this particular mould. Incredibly aggressive in terms of the photosensitization. We sent the samples that we had away. The samples had been in a refrigerator, so I caution you about the exact levels. But the simple message is that it had huge levels of beta-trichothecenes in there. We also had high levels of zearalenone and fuminescens. And when you think about the clinical signs, perhaps the fuminescens were highly involved, but I'd be careful about just describing impact to any one of these factors. But when necropsy was done, there was epithelial erosion, in fact, full penetrance of the mucosa of the abomasum. So abomasal ulceration. These animals were in unbelievable pain. So just looking at three interesting clinical types, somebody asked me, were those photos of facial eczema? They saw the photos, Neil Gannon said, well, is that facial eczema? No, it's not facial eczema. Facial eczema, the key differentiating factor is bile duct hyperplasia, portal necrosis, fibrosis. In this case, which is acute bovine liver disease, which is an unknown syndrome, probably mycotoxic in nature. There's hepatic periportal necrosis, and this has a mild to moderate periacinar necrosis or periportal necrosis as well. And it's characterised by golden infiltrations in the cytoplasm of the hepatocytes. So the last case I'm going to briefly talk to you about is an exploration of dark cutting and high pH meat. Why is high pH meat a problem? Basically because of a lack of storage and infiltration with bacteria. So the producer penalties, it costs Australian producers about 70 million per annum, and the Australian beef industry about $55 million Australian per annum, so about 40. If you look at the sampling period, we looked at animals on that same island as to where the twitchy cattle came from, and the sampling period was over March to June 15, 66 lots of cattle, about 30,100 animals, 66 pasture and 22 silage samples taken, 991 blood samples collected on farm. That was the scary bit. That was dealing with some of those mad cattle. And then 1,100 samples and 1,200 samples of liver. And in these pasture samples and silage samples that we took, what you can see is that if you look at total ergot alkaloids, they were often very, very high, particularly ergocine and ergometrine. And what you also see is that about 40% of the samples exceeded a threshold for being highly contaminated with zearalenone. So really quite nasty pasture profiles, and it probably lends a lot of weight to the stuff that I was talking to you about before in terms of risks of dealing with these pastures. Supplementary feed reduced the risk of dark cutting. significantly. You can see it's gone down from about 14 to 10%. So supplementary feeding, we're not sure why. Maybe it's extra energy, providing glycogen, reducing dark cutting. Maybe it's stimulating more intake of effective fibre, because often these are supplementary feeds. Maybe human habituation before killing might have helped. If you look at the ergocene, we can see that there is an association between presence of ergocene and dark cutting. And also we've got a rather interesting relation with ochratoxin and again an increased risk of dark cutting with higher levels of ochratoxin, and you can see probably up at this extreme end it's probably pretty significant. Zearalenone, grain's normal source but also on pasture, competitively binds to estrogen receptors. You do get I guess reduced production and hyperestrogenism. We've seen it actually as a significant association with poor fertility in heifers raised in New Zealand. So estrogenic responses are present, abortion in ruminants. There's mechanism, reduced size of the corpus luteum in animals artificially fed, and vaginitis, poor reproductive performance. Mammary gland development in virgin heifers, which we've seen in California with zearalenone in silage there. So if you look at this, I guess you've got also the presence of DON with reduced feed intake milk production in New Zealand. And in New Zealand, herds with lower fertility had higher blood and urinary zearalenone resulting from pastures with higher zearalenone. So it comes down to some solutions. The first one I've already mentioned, which is pasture renovation with novel endophytes. Mycotoxin binders obviously are a possibility. I think that if we look at the things that we might be able to do is with better pasture renovation of the old pastures, we should be able to get increased pasture growth, increased carrying capacity, improved weight gain, better reproduction, and turn off stock earlier. So I'd really like to thank my colleagues in this work, the dark cutting work, particularly Kate Loudon, who's the PhD student on that, Pete McGilchrist at Murdoch, Helen Golder for the work, particularly with the Tasmanian outbreak, with the severe mycotoxicosis. And I'd also like to thank Dieter Moll for help with the analyses on the mycotoxins in the Tasmanian outbreak. So thank you.
Could I have some questions from the floor, please? Or are there any, rather than asking for them?
Yeah.
Were you able to identify which molds are they able to select or detect and shy away from?
Yeah, it's an interesting question. Maybe I'll give you a little bit of anecdote in this and a bit of background to that Tasmanian outbreak. The animals that went into that pasture rejected that pasture one day, ate a little bit out of it and rejected it. And because the farmer thought they'd just been fully fed with another pasture, that, he put them back in and then they were hungry. And then that's when they ingested that pasture. Time and time again, we've seen that same pattern of forced ingestion of pasture as a real indicator that there's a problem. And forced ingestion, I'd also say, of silages is a real problem. So, I thought that the presentation earlier about the Poisson distribution of toxins in feed is incredibly important, because one of the things that I think has changed the risk for cattle of mycotoxicosis is the mixer wagon. Now, the mixer wagon's a heck of a good tool, but we see two disease conditions much more frequently now with the mixer wagon. One is botulism and the other is mycotoxicosis, because both have a Poisson distribution. So in other words, they're not all evenly spread throughout the feed. There's a bit here, not much there, not much there. And so what you see is that in terms of the animals themselves, they are selective. One of the extraordinary things in one of those slides I showed you was animals walking through apparently lush, perfect pasture to eat rubbish at the side of the road. The animals in that first photo that I showed you where they rejected feed would literally walk through the pasture and go and find weeds on the side of the road to eat, or the side of the paddock to eat, rather than the pasture. So I can't tell you about which toxins, but by God, they're effective at detecting them. And so one of the practical bits of advice is that if animals don't like a feed, don't force. Yeah. Yeah.
As an anecdote, in some of our research models, we've actually had preference for moldy feed.
Yeah.
In some instances, they've actually competing with the other cattle, getting over our cattle gates to try to get to the moldy feed. So there is, similar to us, in some cases, that they like fermented, differently fermented material. So it's, you know, I think once they eat and they feel bad, they will back off. But
Yeah.
initially, they have a hard time actually detecting, you know, through smell or through other senses. It smells good to them.
So it's probably a learned thing, and I can share a similar anecdote where we had some of probably the worst made silage I've ever seen. It was black, it looked like tobacco, smelt like tobacco, and yet the cattle broke through a couple of fences to get to that stuff and eat it. So, you know, I'm not sure that but they didn't get sick, which is the interesting thing. So, you know, I'm not sure whether simply because it's mouldy it's necessarily bad either, which is, you know, one of those, you know, there's nice studies with white moulds, right? And the studies with white moulds show that in some cases certain white moulds can increase your feed value. So, you know, it's a complex area. Yeah.
What's your experience been with the mycotoxin exposure in dry cows and the effect on calves? DNAs.
To be honest, I don't think I've got any. I've probably just not looked closely enough, I think, is probably the answer. So, yeah, I'm sorry.
I'll make a comment. We went through a herd situation this winter, primarily T2, and a lot of dead calves as a result of that. It was very hard calvings and very dull calves, either born dead or dead soon after.
So what's your experience with it?
So we get a lot of sudden death, but we also get a lot of lethargic calves.
Yeah.
With that first 30 days or so, very difficult to deal with. Very much so. Calf ran into the middle.
Cows calve okay? Do the cows calve okay?
Yes, they do typically.
Mm.
Right down the back, please.
One question, what's about the Clostridia issue in Australia, according or in case of botulism?
So maybe just to repeat the question and make sure I've got it right, what's the situation in Australia with regard to clostridial infection, but particularly botulism? Yeah. In Northern Australia, and we're seeing it in increasing numbers probably in Southern Australia, have regular outbreaks of botulism. It's usually been associated with animals going into silage. It's not a plan to put animals in silage, but happens pretty frequently. And the ones that seem to cause us most grief is tortoises. Tortoises can be spectacular. And ducks. Snakes also are all reasonably high-risk inclusions. We've seen equine deaths associated with rabbits. So all of those go in, and we do see quite frequent expression. Those of you who don't know bandicoots are another one that kind of go in pretty badly as well. So it's mostly that, and it's reasonably common to the point where we now recommend vaccination for botulism as a specific vaccination.
Everyone's scared of Australia's snakes as it is, and now you tell them this.
At least they don't bite you that time. Yeah.
If there's no other questions, I'll ask everyone to thank Professor Lang.